Hello everyone, welcome to MBA Karo. Today is day 26 of hot summer and we are in the last 5 days of this series, and in this video we are going to solve sets based on quantitative reasoning. Now what is quantitative reasoning? As you can guess, it is some mixture of quant plus reasoning. So basically the kind of problems that test your numerical ability, or you can call them as number puzzles also. So these are the ones, the DILR sets, which are a mix of both, which have numerical data and test your reasoning skills with numbers. So we shall be solving a variety of sets in this. So please do watch these sets and at first try to solve them on your own. If you are unable to solve them, then try to look at the solution. If you are new to the channel, please don't forget to subscribe to the channel. This is the best resource that you will find on internet for all MBA entrance examinations, and follow us on Instagram and Telegram as well. So we have reached the last few episodes of this. We are on 26th of June on quantitative reasoning. We have one more class left on geometry, one on sentence filler, one on LR topics that will include cubes, binary logic, etc. And we will have one session on modern maths. So we have covered the remaining portions, and in that we have covered a test on all the topics that are tested in CAT. So please do watch all these videos, and I can assure you that if you watch these 30 videos, it will help you a lot with your preparation, and you would be able to perform much better in the examinations that you would be writing. In case you are looking for CAT preparation and are looking for our structured course, you may do so by enrolling in our CAT batch, and you can use HOT to get 20% off on this. And we will be launching a crash course in September. So in case your basics are clear and you just want to practice like in a disciplined manner, practice questions in the last few months, so you can enroll in that crash course also. So that will be announced very soon. Okay, so try to pause the video, try to solve the set, and then look at the solution, and then see that how much time you took to solve the set versus like how much time I take to solve the set. Of course, I know I would directly start solving the set because probably I have solved these kind of problems in the past. But the thing is, like, try to understand the optimum approach, the thought process, and the do's and don'ts in each of the sets. Okay, so we will begin now. So watch this set, solve it, and then look at the solution later. So this is a set which is based on crypt arithmetic. Okay, so this topic is called crypt arithmetic. You can find more videos on crypt arithmetic on my channel Aptitude Jab. Okay, so I have a YouTube channel which is by the name Aptitude Jab. This is the largest source of DILR preparation. Okay, and unfortunately not many people know about this channel. Okay, good for you. So please subscribe to this channel, and in that you can search for crypt arithmetic. You will find some sets including this one also. Okay, so it says that there is a multiplication of two 3-digit numbers. In the representation, each of the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 except 1 has been coded with a 1 letter with distinct letters representing distinct digits. So each digit represents a different letter. Each digit is represented by different letter. Okay, so now how do we proceed with this multiplication? Okay, so whenever we have to multiply numbers, so what we do is, first of all we multiply with B, then we multiply by O, and then we multiply by B. So this is basically Bob into B. This is Bob into O. Okay, now this, of course, this digit will come down as it is, which is perfectly fine. O plus O is E, fine. What we notice here is that when we multiply B by B, we get Y. So it's a digit, we can't tell which digit it could be. If we multiply O by B, we get O as the digit. Okay, so this is the point that we need to focus on, that O multiplied by B gives us O as the digit. So how is it possible? So O into B is equal to O. So one thing that you can talk of is that b is equal to 1. So if you multiply any digit by 1, so let's say if you multiply 2 by 1 you get 2, 3 by 1 you get 3, okay, that's what you will get. So one possibility is that b is 1 and hence O into b is equal to O. Now if b was 1, so we will see these cases and try to figure out if b was 1, so b into b, 1 into 1 will be 1, but it says distinct letters represent distinct digits, so b cannot be 1. Okay, b can't be 1 because this should have been 1 here. Okay, and also like if we have b is equal to 1, so it should be Bob will be Bob only, like Bob multiplied by Bob should have been Bob only, so that is not possible. Next thing, how do we get the same digit? Like O into B gives O as the same digit, right? So one of the things that you can look for is 5. Think 5 multiplied by digits is what? 5 into 1 is equal to 5. Okay. Then 5 into 2 is 10, that ends in 0. So when 5 is multiplied by a digit, it is either 5 or 0. Okay. Now if we multiply 5 by odd digit, 5 into odd, the last digit is 5. Okay. So 5 into odd, the last digit is 5. So 5 and same digit repeated. So O should be 5 and B should be an odd digit, so that we get the digit as 5. Okay. So that is another possibility. And let us think of some more possibilities such that you get the same digit. Okay, so think of like 1 getting multiplied by any digit, and do you get 1 as the result? 1 multiplied by 1 gives you 1 as the result. Okay, but with no other digit you will get the same result. Okay, so we have already ruled out the possibility of 1. Now let us think of 2. 2 multiplied by some digit giving us 2 as the result. Okay, think of that. So O into B gives you O. So let us say O, this is B. So B is not 1, that we have ruled out. So 2 into some digit ending in 2. So if you see, you can say 2 into 1 is 2. Okay, but B is 1 is not possible. Then 2 into 6 is 12, isn't it? That ends in 2. So 6 is a possible number. Let us see with other digits. 3 into 6 is 18, so ends in 8. 4 into 6 is 24, so ends in 4. Then 5 into 6 ends in 0. So again, if we see 6 into even is giving the same digit. So even into 6 gives the same even digit. Okay, so if you have like this observation, if you make, so if you make 8 into 6, that is 48. So even digit multiplied by 6 give the same last digit, right? So we know that one possibility is that O is even and into B is 6, right? Now let us see that does it match. So if we put B is equal to 6 here, so 6 into 6 is 36. Now we are saying that these are distinct letters, so this possibility is not there, like it can't be 6 because 6 into 6 is 36, so Y should have been 6. So this gives us the possibility that O is 5 and B is an odd number. So we have 5, some odd number, 5 and some odd number. Okay, now we will do this multiplication. So B into B is Y, that is fine. Then B into O gives us O. So B into B is Y, fine. Then we do B into 5, we get 5 as the digit, right? And this is an odd number. So odd into 5 gives 5 as the last digit, right? We discussed this. Now if we are still getting 5 as the last digit, that means there is no carry from behind. Okay, if there was a carry, then the digit would not have been 5. So that means B into B is no carry. Okay, this should not give any carry because then B into O will be 5. So Now what odd number cannot give any carry? So if we see 1 into 1 gives us 1, but we have ruled out the possibility of b being 1. Then we can have 3 into 3 is 9, that does not give any carry, and y is different, so that is satisfies. Now if you take more than 3, then it will give a carry. So from this logic we figure out that the number is 353 into 353. So let us test all the numbers and see that if it matches. So 3 into 5, 3 into 3 is 9, 3 into 5 is 15, 1 carries 9 and 10. Okay, then 5 into 3 is 15, 1 carries 25 plus 1 is 26, 2 carries 15 plus 2 is 17. Okay, and the last digit is also 1059. So we will see the sum. So 5 plus 5 is 10, 1 carries, this is 16, 1 carries, so 13 plus 1 14. Okay, 1 carries, that is 2, and this. Okay, so this is what we will get as the product. So we can verify all the digits and see that if all things match. So BOB is like 353. Okay, so 353, and see that if O is used, wherever O is used, it is representing 5 only. Okay, so that is correct. Then we have, then if you look at MEOY, Y is 9, so Y is represented as 9 all places. Okay, O is 5, that is correct. E is 0, so E is represented as 0 and these places. So here all we have 0 0 0. So fine. M is 1, so 1 1 1 and 1. Okay, so M is also satisfied. I is 7, which is used only once. L is 6, it is used here and here both. We have 6. Okay, so this is how we will get the solution. So you can look for all digits, each one has been used for a different letter. Okay, so now let us look at the questions. What number is represented by Bob? So Bob is 353. Okay, what is the value of MARLEY? Adding this, so this is 7, 13 plus 9 22. What digit does I represent? So I is for 7. Which digit is not present in the above multiplication? Okay, so we have different digits. 0 is present, 1 is present, 2 is present, 3 is present. Okay, so let's find out which digit is not present. 0 is present, 1 is present, 2 is present, 3 4 5 6 7, 8 is not present, right? If you look at the entire multiplication, 8 is missing in this. And the last question, which of the following represents Bob plus Bob? So Bob plus Bob is 353 plus 353, which is 706. So 6 is represented by, this is the third last digit, that is L. Okay, and 0 is by E and 7 is by I. So I, E, L, that is the representation of Bob plus Bob. So this was the solution to this set. So do let me know in the comments that were you able to solve this set on your own, and how much time you took it to solve the set. Well, let's move on to the next question. This would be comparatively easy. So it says that there are people, Adam, Bob, Charles, David, A to F, they participated in a quiz. There were total 15 questions in increasing difficulty level, and the score for answering a question was the square of the question number. Okay, so it was the square of the question number. For example, if someone answered the 8th question, they would get 64 points. Okay, so simple thing to understand. Only one person answered a question. Okay, so one question was answered by only one person. None of them scored more than 300. Fred was the top scorer. Charles answered 3 consecutive questions. David answered only one question, and the others answered 2 questions each. Okay, so we have question number 1, 2. So we will make a sort of table like which question has been answered by which person, and basically the score that they can get in that. Okay, so let's put that's question number, that will be the score, and we will put the person who answered it. So question number 1 2 4 5 6 7 8, 9, 10, 11, 12, 13, 14 and 15. Okay, so the scores will be 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, then 144, 169, 196 and 225. So these are the scores that they will get for answering the question. Okay, none of them scored more than 300. Charles answered 3 questions, David answered only 1 question, so 4 answers, and the others answered 2 questions each. So that means a total of 12 questions are answered, 3 questions are not answered. Okay, 12 answered, 3 not answered. Adam and David had the same total. Okay, so Adam answered how many questions? David answered only 1 question and Adam answered 2 questions. Okay, so that means Adam answered, let's say Adam answered 2 questions, A and B, that is equal to C square. Now this is something has to do with geometry as well, like if you are not only just about numbers, it's about, like, see, there also it's the number thing which is used. So that is Pythagoras theorem. Isn't it? So you'll have to think of 3 numbers such that a square plus b square is equal to c square. Okay, so we'll think of some triplets. 3, 4, 5 is one such set. 3, 4, 5. Then another set could be 4. We do not have any such pair. Then we have 5 does not also. 5, 12, 13 is one such pair. Okay, 5, 12, 13 is another pair. Then we have another pair as 6, 8, 10. Right, among these numbers we can get 3 pairs and even one more pair, that is 9, 12 and 15. Right, so we get these many possibilities. So we could have any of these as the values for A and D. Now it says Bob's total was equal to points scored by Adam while answering one of the questions. Okay, now it says that Bob's total is equal to, and Bob has answered how many questions? Bob has answered 2 questions. Right, so Bob answered 2 questions. His total was equal to the points scored by Adam while answering one of the questions. So Bob, let us say, scored, let's say he answered question number X and Y. So Bob's score is X square plus Y square, that is equal to points scored by Adam while answering one of the questions. So let us say Adam answered one A and B. Okay, so Adam is A and B and this is David. Okay, so that is equal to A square. Let's say any of the values, it's not necessary that A is less or high. So X square plus Y square is equal to A square. Okay, also Bob's total was half of Ed's total. So we are given certain conditions like this, so possibly this would help us crack the set. So Bob's square total is the sum of 2 square numbers and Adam should have one of those. So if you look at this 3, 4, 5, okay, so could it possible that Bob answered 3 and 4 and his total is equal to 25? Okay, Adam, one of the questions is 5 and another is 12 and 13. So this is a possible code that we can get. So let us say Bob answered this and this. So Bob's total is, so we will write the totals also, A, B, C, D, E, F. So Bob's total is 25. Okay, now we are saying that Adam answered 5 and 12. So this is Adam and this is David. Okay, so Adam is total is 169. David's total is also 169. So that also satisfies. Right, his total while answering one of the questions. So one of the questions was 25 in Adam, that also satisfies. Okay, now another thing is given that Bob's total was half of Ed's total. So Bob's total is half of Ed's total. So Bob's total is 25. So Ed's total will be 50. So 50 is only possible with 1 and 49. So this is Ed. Okay, so we got this also. Now we are left with 2 more people, right? One of the conditions say that none of them scored more than 300. Okay, and also Charles answered 3 consecutive questions. Now Charles can answer either these 3 or these 3. If we add this will become 302. So if you add these 3 numbers, it becomes greater than 300, which is not possible. So Charles answered these 3 questions. So this is Charles, Charles and Charles. Okay, so this is done. So Charles is 145, 245. Now Fred answered. Fred was the top scorer, and Fred has answered 2 questions. Okay, so Fred has to answer 2 questions. Now let us see which 2. So Fred can answer one of these questions. Like Fred can answer, Charles total is 245. So Fred's total should be greater than 245. Okay, so if you take, Fred has to be on the higher side. So if you take 225, right? So along with 225, we cannot take these. This will make it 300, greater than 300. So it could be 36 and 225, one possibility. Okay, now suppose we do not take 225. Okay, so we do not take 25. 196, this will give us greater than 300, and if we take 196 and 36, that is 232, which is less than Charles. So that means we have to take 225 and 36. So these are the questions answered by Fred. That will give us the answer 261. Okay, so it was an interesting set dealing with squares of numbers. Okay, now these numbers are missing, so these were not answered by any one of them. Like 11, like you would say 11, 14 and question number 2. Okay, so what is the maximum score of any of these participants? So maximum score is 261. What is the difference between the scores of Charles and Adam? Charles is 245, Adam is 169, so the difference is 76. What would be the score from the 3 questions not answered by any of these? So that will be 196 plus 121 plus 4, so that is 321. And who answered question number 7? We can say that it was Ed who answered question number 7. So this was the solution to this set. Do let me know that were you able to solve this set. So for every set, let me know in the comments that which was the set and like which ones were you able to solve or not able to solve. I hope you are enjoying this session. So please do like this video and share it with your friends. You can share the sets also, right? So the PDF of this will be available on our Telegram group. You can share those sets with people and challenge them that how many can they solve in how much time. A company employee generates a series of 6-digit product codes in accordance with the following rules. So there are certain rules for 6-digit product codes. Now this is an easy set as compared to the previous one. Okay, and it has simple instructions. It says the code uses the digits 0, 1, 2, 3, 4, 5 and no others. So these are the only digits used. The digits are counted from the left end. So this is the first digit. So let's say 1, 2, 3, 4, 5, 6. So if I put 1, 3, 4, so this is the first digit, second digit, third digit and so on, right? So this is the order in which the digits are counted. Alright, so we are given that each digit occurs exactly once in any code. Okay, the second digit has a value twice that of the first digit. Okay, so we will have to think of possibilities. So first digit can be 1, second digit can be 2. Okay, then we can have 4 more digits, and first digit can be 2, second digit can be 4 and we can have 4 more digits. Okay, so simple ones. We have 4 more digits to arrange. The value of the third digit is less than the value of the fifth digit. So this is less than this digit. So this shows that this is smaller, this is larger. Okay, so you can use similar notations while doing your rough works. The fourth digit should be an odd number. So this is an odd number. Okay, so we can form multiple digits. They have not asked that how many digits, how many codes can be formed, but they have asked particular questions. So let us look at those particular questions and answer them. So first says, what is the smallest number that can be used as an acceptable product code? So smallest number, first of all, the first digit should be 1. Okay, second digit should be 2. Now we are left with 4 digits. Okay, Now whenever we have to make a smallest number, let us say I have digits 1, 2, 3, 4, 5 and I have to make the smallest number. Okay, so we have the numbers in increasing order. If I have to make the largest number of the digits, I should have 5, 4, 3, 2, 1. So basically the number should be in decreasing order. From this should be decreasing order, this should be increasing order, unless there are certain constraints here. Okay, so the smallest number we have to make, so we will try to put the smallest digit on the left hand side. So let us try to put a 0 here. Okay, so can we put 0? Yes, perfectly fine. It says that it has to be less than this digit, which is perfectly fine. Okay, now this should be an odd digit, so try to pick an odd digit in the increasing order. So it can be 3, so we can have this as 1, 2, 0, 3, 4, 5. So the answer is 1, 2, 0, 3, 4, 5. What is the biggest number that can be used as an acceptable product code? So biggest number we will have to use 2 and 4. Okay, now we will try to put them in the decreasing order. Okay, we have to put in decreasing order, but this digit is less than this digit. Okay, so if we put, like, we cannot put 5 here because it has to be less than this. Can we put 4 here? 4 has already been used here, so we can put at max 3 here. Okay, so we can put at max 3 and it has to be less than this digit, so it will be 5. So we have used 2, 4, 3, 5, so we are left with 0 and 1. So as I said that we need to arrange in the decreasing order from left to right, so we will put 1 here and then 0 here. So this will be the largest code that we can use, that can be formed using these digits. Okay, now we are given some condition. If the last digit of an acceptable product code is 1, then it must be true that. Then which of the following should be true? So this is a set which requires you to focus on individual questions rather than solving a group question. Okay, so you need to check each question separately. Okay, now it says that the last digit is 1. So last digit is 1. So that means first two digits are going to be 2 and 4. Okay, 2 and 4 are the first two digits. Then this digit is smaller than this digit. Okay, so and this has to be an odd digit. Okay, so this is an odd digit. So we are left with 3. Okay, so if we put 3 here, we have to have 0 and 5, so not possible. So we cannot put 5 here because this has to be greater, so we have to put 0 here. Okay, so we have to put 0, then we can have 3, 5 or 5, 3. Okay, so let us see the conditions. The first digit is greater than the fifth digit. First greater than the fifth digit, false. The second digit is smaller than the fifth digit, can't say, because in one case it is smaller, in another case it is not. The third digit is 0, is for sure correct. Okay, fourth digit is 3, is not necessarily true. So we have to find which of the statements is necessarily true. So only the third statement, that the third digit is 0, is true in all cases. Which one of the following must be true about any acceptable product code? Okay, so which of the following must be true? So let's see, the digit 1 cannot appear in the fifth position. So it is very simple, because first option, when if you have fifth digit is like, is it possible to have, is it possible not to have 1 in the fifth position? In this case you might say yes, but if you consider this scenario, okay, if you consider this scenario, we can have 1 here. So if you consider this scenario, we can put 1 here and 0 here, isn't it? So that is possible. So not we can't say that it is true. Digit 1 always appears in some position before digit 3. Okay, 1 appears before 3. Now can 1 appear before 3? Not necessarily. We can put 1 here, 0 here and 3 here. Okay, so that is quite possible. The digit 0 appears in some position after digit 4. So 0 appears 4 in this, after 4 in this case. And does 0 appear after 4? We have to put an odd digit. We can put 0 here. So 0 will appear before 4. Okay. The digit 3 can appear in the 3rd, 4th, 5th or 6th positions. Okay, so digit 3 can appear in all positions. It can appear here, like we saw 3 here, we saw 3 here. Okay, we can see 3 here also, and possible that we can put in the, so we have seen in 3 positions. Okay, so we have seen in the 4th position, we have seen in the 3rd position, we have seen in the 5th position also. Let us make a case wherein it is present in the 6th position. Okay, so we put 3 here. So let us make 2, 4, and that put 0, 1, 5, 3. So quite much possible. So we can put 3 on any of the positions. So this statement is true. How many product codes are acceptable such that the 3rd digit of a product code is not 0, right? So the 3rd digit should not be 0. So we will make the cases here. So we'll start with 1, 2, okay, and we'll start with 2, 4. So 3rd digit should not be 0. So if this is not 0, okay, then we have to have an odd digit here. So that cannot be 0. This cannot be 0 because this digit is larger than this digit. So this last digit has to be 0. Okay, last digit has to be 0, and we have to have 1, 2, 3, 4, 5 are remaining. So we cannot put 4 here. So we can have 3, 4 and 5, and we can also have 1, 2, 4 can be put here, 3, 5 and 0. So we have this case wherein we are not putting the 3rd digit as 0. Okay, now if you take the case with 2, 4, this cannot be 0. Okay, 4th digit anyway cannot be 0, 5th cannot be 0. So last digit has to be 0. Okay, now we are left with 1, 3, 5. Okay, 1, 3, 5, and we can put 1, 3, 5, right? We can put 3, 1, 5. Okay, and we can also put 2, 4, 1, 5, 3, 0. So that is also permissible. So if we put 1 here, we can have put 3 and 5, and if we put like 1 here, so if we put 2, 4, 1, we can put 3, 5, 0, 2, 4, 1, 5, 3, 0, because this digit is larger. We cannot put 5 here. So we have a total of 5 such numbers. Okay, so it was a difficult one. So like individually the questions are challenging, right? Although the overall instructions are very simple, but individually the questions are time taking. Last one, any of the following pairs could be the 3rd and 4th digits respectively except. So 3rd and 4th digits. Okay, so we need to tell that which of the following cannot be the 3rd and 4th digits. Okay, so let's again, we'll have to make some cases. So the condition is that 3rd and 4th digits could be there. Which of the following cannot be the 3rd and 4th digits? So 4th digit is odd number. Okay, so that is fine. Now 3rd digit is, now see this, like you need to not make cases, just look at the options and try to answer it. 3rd digit का condition क्या है? 3rd digit is less than 5th digit. Okay, so 3rd less than 5th, and 4th is odd. So 4th is odd in all these situations, so which is perfectly fine. 3rd is less than the 4th digit. So suppose if we put the 3rd digit 4, then what should be the 5th digit? So we have 6 digits, 1, 2, 3, 4, 5, 6. If we put these two as 4 and 5, it has to be greater than 4. Then 5 is already placed here. So this cannot be the 3rd and 4th digits. Others are possible. So you might have seen in these cases, like 0 and 3 we have seen in this case. Okay, 1 and 5 we have seen in this case, right? 3 and 1 we have seen in this case. So all others we have seen in the cases that we made in the question, but 4 and 5 cannot be the 3rd and 4th digits, because the 5th digit has to be greater than 4, and 5 is already used in the 4th position. So this was another set which had like simple instructions, but each of the questions was time consuming. Okay, so here's the next one. It is again quite interesting set. It says that in a country called Primistan, the currency is called Abhajya, and it is available in exactly 5 denominations. Like the symbol is @ 2, 3, 5, 7 and 11. each of the 5 persons, Pranav, Reena, Ian, Mushtaq and Emily, so their names are also prime, deliberately created in that manner, had notes of exactly one denomination with them, and no 2 persons among the 5 had notes of the same denomination. So they had only one kind of denomination, and like no 2 persons had the same denomination. On a particular day, the 5 persons visited a bookstore, and each one of them purchased a different book. Okay, the amounts that these people paid the shopkeeper were 42, 105, 65, 70 and 75. Further, the number of notes that each person gave the shopkeeper was distinct. So basically the amount is the denomination into number of notes. Okay, so these are 5 people, PRIME. The amount with them are given as 42. So we'll write a bit spaced apart so that we can write the cases also. So the person has 42, 105, right, 165, 70 and 75. Okay, so now they have the denomination, okay, and the number of notes, how many notes they had, right? So that is given here, and then some more information is given. So it says that however, the amount that each person paid the shopkeeper was more than the price that the book they purchased. So they gave these amounts, it was greater than the price of the book. So what happened? The shopkeeper returned the excess amounts to each of the form of 3 notes each, okay, of 3 different denominations. 3 notes were returned and 3 different denominations which were different from that in which the person had paid the shopkeeper. Okay, so we will come to this part later. Let us first find out which denomination which of these persons could have had. Okay, so let's read the conditions and try to find it. So if you look at 42, it can be 2, 3 or 7. Okay, 105 could be 3, 5 or 7. 165 could be 3, 5 or 11. 70 could be 2, 5 and 7. Okay, 75 could be 3 or 5, right? So these are the possible denominations a person can have. Now each of them has a separate denomination, so it has to be 2, 3, 5, 7 and 11. Okay, so now if you see, 11 is present only once. Okay, so 11 is present only once, that means this person will have 11 for sure. Okay, so if he has 11, so he has 15 notes of the denomination 11. Okay, so pay attention to this. This is a very beautiful set. Okay, and you need to look at this thing carefully, that this has to be, he has to have 11 notes, right? Now it is given that the number of notes that the person gave was distinct. Now no one else can give 15 notes to the shopkeeper. Okay, so now if you see 3 and 5, if you take 5, it will be 5 into 15, that makes 75, but this person has already given 15 notes, so this person cannot have 5 as a denomination, hence will have 3 as the denomination, and that person gave 25 notes. Okay, now 3 is ruled out, so we will remove 3 from here and here. Okay, now it is 257, 27, 357, so it is present everywhere. Okay, now again if we see 7, 105, if you divide by 7, that will again give 15, so that is not possible. So it means this person has notes of 5 and he gave 21 notes to the shopkeeper. Okay, so 5 is also done. Now we are left with 2 and 7. Okay, now if you divide this by 2, you will get 21. Okay, again this gives us that 2 is not possible, so this is 7 and this person gave 6 notes. Okay, so this value will be 2 and this person gave 35 notes to the shopkeeper. So such a beautiful set with numbers. Okay, I hope you enjoyed this, solving this. If you were able to solve the set on your own, that's great. If not, hope you must have loved the solution part. So it says, what was the total number of notes paid to the shopkeeper? So this, add these, you will get the answer. So this is 60 plus 42, 60, and 75 plus 27, 102 notes. Who paid the highest number of notes to the shopkeeper? So it is Mushtaq who paid the highest number of notes to the shopkeeper. Okay. Now we come to the remaining part of the passage, right, which says that this was the number of notes, the amount paid. Now we talk about the remaining thing, that is amount returned. Okay, returned is, it says amount was returned in the form of 3 notes each of 3 different denominations. So for example, P paid 42. Okay, so he paid in 7. Okay, so P would, like for example, we are asked a question about Ian, so let us use Ian. So Ian paid in the form of denomination of 11. So Ian paid 165 using 11. So he will be paid back not in 11, he will be paid in 2, 3, 5 or 7. Okay, so he will be paid in 2, 3, 5 or 7. So what could be the amount returned to him? So it is said that these are 3 different denominations and 1 of each. So 3 notes each of 3 different denominations. So basically 1 note of each type. So he can be written like, see, he has to be written 3 notes. So add 3 of them together. So it can be 10. So we excluded 7, we got 10. If you exclude 5, so what we get? 2, 3, 7, that is 12. If you exclude 3, 5, 7, 2, 14. If you exclude 2, he could be paid back 15. Okay, so that is the amount returned to him. So amount returned is this. So the price could be 155, 153, 151 or 150. Okay, so now 149 is not a possible amount. So these could be the price of the books, and this cannot be the price. What could be the price of the costliest book purchased by Emily? Now Emily paid 75, okay, and was returned 3 of the values. So she paid in 3, so she has to be returned 2, 5, 7 and 11. Okay, so the return should be least. Okay, so we will be returned the least amount. So if you have to purchase the costliest, so that means the amount returned to you should be the least. So the amount returned least will be 257. So this is 12, 14. So 75 minus 14 is 61. Which of the following is not true regarding the price of the book purchased by Pranav? So we need to tell that which of the following is not true about the price. So he purchased of 42. Okay, now he will be returned 5, 11, 2, 3, 5 or 11. Okay, so these are the amounts that are returned. Okay, so let us see that which of the following cannot be the amount that got returned to him. Okay, so if we take 2, 3, 5, so it could be 42 minus 10. 42 minus that could be 32. So if we take 2, 3, 11, that is like 5, 16, that is 26. Okay, 42 minus then we can have 2, 5, 11, that is 16 plus 2, 18, and another could be 42 minus 11, 5 and 3, so 16, 3, 19, 24, and this could be 23. Okay, which of the following is not true out of these? So if you look at this, it says that it is a multiple of 3. Okay, so multiple of 3 is possible. It is a multiple of 5, it is not possible. Okay, which of the following is not true? So he can have multiple of 5 not possible, multiple of 8 is possible, and prime number is also possible. Okay, so the multiple of 5 is not possible for this person. Okay, so this was another interesting set using numbers and especially prime numbers. I hope you loved solving this set. So I hope you are enjoying this session. So please don't forget to like this video. Let's move on to the next set. This is again a beautiful number puzzle, and it is related to something related to averages. So it says that 18 students appeared in the mock test and got distinct marks. Okay, distinct marks means each of them got different marks. They were placed into 6 groups, G1 through G6, 3 in each group based on their marks. Okay, so they were based on their marks. They had to be counseled by 3 mentors, Atharv, Garv and Parv, such that each mentor would counsel exactly 1 student from each of the groups. Okay. The table below gives the lowest and the highest scores of the students in each of the groups. So the least score is given and the highest score is given. So one of the scores which is in between is missing in each of these groups. Okay. So now it says that Atharv wanted to counsel the students who scored the least from each of the groups, but Atharv was late in arriving and hence he counselled Gaurav instead. So he wanted to counsel all these students and he missed one of the students, and instead of him he counselled Gaurav. The average score of the students he counselled increased by 5 due to this change. Okay, so basically we will have to find which are the people that these guys counselled. Okay, so Atharv was supposed to counsel these people. Okay, now it says that the average he counselled increased by 5 due to this change. So if the average goes up by 5, what is the average? Average is sum upon number of people. Okay, so if the average is going up, that means sum will go up. Average goes up by 5 and there are 6 people, so sum will go up by average into number of people, that means sum will go up by 30 marks. Okay, so the score that is present increased by 30. Okay, now we will see one interesting thing. So he had to counsel 17. If I add 30 to it, so it says that this will be 47. Okay, which is not within this group, so not possible. If I add 30 here, it will be 60, not possible in this group. If I add 30, it is 82, which is possible. If I add 30, it will be 129, 148 and 176. So these are out of this range. So this means instead of 52, he counselled 82. So we get the person of this group, right? The number is 82. So let us write the numbers that he counselled. He counselled 70. He counselled the person with 30 marks. Then instead of 30, he counselled 82. Okay. Then 99, 118 and 146. So these are the numbers, these are the marks, right, for the people who he counselled them. Okay, so one of these numbers is like 52, which will be counselled by some other person, right? And then the next thing is the scores of students. Like one of the questions can be answered. The score of Gaurav is 82. The scores of the students that Parv counselled from G1, G2 and G3 are in the ratio 2:3:4. Okay, so G1, G2, G3, the values should be 2:3:4. Now if you look at this group G3, the values are 52, 82 and 89, right? So it has to be a multiple of 4, which is only present here. So Parv will counsel 52 here, and hence 2:3:4 will be 26, 39 and 52. That is the only possibility. Now if this is 26, so Gaurav will counsel 28 and 30, 39 and this will be 49, 82, 52 and 89. So these are done, right? Now the scores of the students that Garv counselled from G4, G5 and G6 are in the ratio 6, 7, 8. Okay. Now in 6, 7, 8, one of the values that is pending is 114. Okay, here one of the values is 145 and here it is 172, right? Now the value has to be greater than 99. Okay, so like he cancels, it says that Garv cancelled 6x, 7x and 8x. Okay, now 6x is greater than 99. So if we take 102, okay, so if we suppose we take 102, so this will be 119 because it is 17 and 136. Now this range is not in 136, so this is not possible. So if we take x is equal to like this is 17, if we take 18, then it will be 108, 126 and 144. Now again this lower value is 146, so this is also not possible. Highest value is 114, so we will have to take 19. So this will be 114, 133 and 152. So these are the three values that we will get. Now 19 and 199 and 114 are done, so this is missing. Okay, and then we have 118 and 133 done, so this is 145 that will come here, and the last value, that is 146, 152, a central value is figured out, 172 is missing, so that will be in this case. So this is how we will get the values of the remaining, like we are given for each group we are given the higher and lower value, the middle value was missing. So using this information we could figure out the middle values of 5 of these, but not for one of the persons. Like this value cannot be determined yet. So this question we answered 82. Which of these is not the score obtained by any of the students? So which of these is not a score? So 26 is a score, 82 is also a score, 126 is not a score, right? We don't see 126 as the score because see, if you see this range, it is between 99 to 114, so it cannot be 126, and 152 is already a score, so 126 is not a score. What is the sum of the scores of the students counselled by Garv? So we will have to add these numbers. So if you add the numbers 29, 40, 28, 49, 77, 166, 280, 280 plus 285, you will get 565. So this total is 565. The average score of the students of G3 is how much more than the average score of the students of G2? So we will have to find G3 ka average and G2 ka average. So G3 G2 average is, it is 8818, that is 39.33, and G2 the average is G3 the average is 134 and 223, that is 74.33. So when you subtract, you get the difference as 35. What could be the least sum of the scores of the students counselled by PER? So you have to find the least sum. Now these totals we already know, and we are given that each one of them had distinct marks. So distinct means different values. So 99 is a number present over here, so we will try to put the minimum, that is 100. Okay, so this is 117. Okay, these three add to 117, 217, 217 plus 31, 217 and 317. So 534 would be the minimum total that we will get. Okay, so this was the set and its solution. Now let's move on to the next one. It is it looks a very short one, the text, but the logic is quite intense, and I'm sure that many of you wouldn't have been able to solve this one without looking at the solution. So let's see this set. It says that there are 3 houses of a school, Ashok, Vivek and Gandhi. They competed in a quiz. The 3 houses participated in a series of rounds. Points awarded for first, second and third place in each round were A, B and C respectively. with A greater than B greater than C greater than 0 and all point values being integers. So A, B, C are the points given for each round. Ashok House finished with 32 points overall. Gandhi House won the rapid fire round. So one of the rounds is rapid fire round and finished with 11 points overall. And Vivek House finished with 17 points overall. So this is the only piece of information which is given to us. Based on it, we need to find the value of A. We have to tell in how many rounds Ashok House finished first and some more questions. So this is a very intense question wherein you have to like the very first thought process. If you build that thought process, you will be able to probably make cases and solve it. But if you cannot build that initial thought process, you will end up spending a lot of time but unable to crack this set at all. Okay. So let's look at the solution. So what we are given is, we are given the points of these three houses, total points. So what is the grand total? 32, 11 and 17, the total is 60. Okay. Now one thing that you need to consider is each round had same points distributed. So each round the points distributed are A plus B plus C each round. Okay, first, second, third get A, B, C. Now total is 60. So every round you are distributing the same points. So that means A plus B plus C factor of 60. Okay. So now we will think of how can we get factors of 60. Okay. So 60 is and what is the minimum value of A plus B plus C? A is greater than B greater than C greater than 0. So we need to think of factors of 60 at least starting from 6. So we can have 6 into 10. So this is ABC and this is the number of rounds. Okay, so 6. Then we can have a total as 10 and rounds as 6. We can have a total as 12 and rounds as 5. We can have total as 15, 4 rounds, and we can have let's say 23 rounds. Okay, we can have 30 and 2 rounds. Now let's remove the extremes. How to remove the extremes is, now Ashok House finished first with 32 points overall. So it must have won most of the rounds, right? 32 points, which is basically greater than half of the points. So it is winning by more than half of the points. So basically must have been the winner in most of the rounds. Now if we take, let's say 30 point, like obviously this can easily be eliminated. So A plus B plus C, if we take 30, so the first the winner, if like, and then Vivek House finished with like Gandhi House has to win one of the rounds and should get 11 points. Okay, the winner would get definitely, like A plus B plus C is 30. So A is greater than, so A will be greater than 10. Okay, so in one round itself they will score more than 10 points. Okay, and obviously like in the other round also they will score some points. So we can easily eliminate these cases. Similarly, if you distribute 20 points per round, 20 points as the total, right? So you will at least make 8, 7 and 5. Like let's say if you have to make at least 7, right, to make 20. So 7, 7, 6, which is not possible. Then you will have to make 8, 8, 7, 5 if you take. So if it wins one round, 8 points. In another round it can score 5. So this is also not possible. Okay, so we try to remove the extremes from the top as well as from the bottom. So if you take ABC as 3, 2, 1, and we are saying that we are having 10 rounds. Okay, so if this team has to win 32 points, so even if it wins all 10 rounds, can reach only 30 points. So this is also not possible. So again one of the possibilities removed. So now the total could be 10 and 6 rounds, or 12 5 rounds, or 15 4 rounds. Okay, now 10, how can we make 10? Think, how can you make 10? So we can make, and see, it has to make more than 32 points. So try to make more than half of it. Okay, that's the logic you'll have to use, that a team is getting 32 points overall. So even if it wins all the rounds, it should have more than half. So that means the winner should get more than half for sure. So we have to give more than 5. So we can give 6, 3, 1. Okay. So if you there are 6 rounds, and if you make them win 5 rounds, they cannot win all rounds. Gandhi House has to win the rapid fire round. So if you make them win 5 rounds, so they will get 30 points. Okay, 5 rounds, they will get 30. You need 2 more points to reach 32. Now 2 is not a marking scheme in this. So probably this is also not possible. Okay, so it requires a bit of hit and trial here. Now if the total is 12 points per round, and if you give more than half, that is, you will have to give at least 7 points. So 7, we can give 7, 3, 2 or 7, 4, 1. Now if you make them win 4 rounds, they have won 28 points, because 1 round they cannot win. Okay, and then we need to have 4 more points to make 32. So possibly we can take this as the case 7, 4, 1. Okay, now we are left with 15 also. We can check with that also, but let's solve this first, because we have figured out a crucial value. So let's check this first, or let's check this and eliminate this case. That would be a better thing to do. However, in the examination, if you have hit the right set of values, solve with that and go ahead, not to check the others for elimination. So 15 means this team should get minimum 8 points. Okay, and there are 4 rounds, so 8 into 3 will give us 24. Okay, we need to score 8 more points to get 32. So the team needs 8 into 4 for 32, not possible. So if you give 9 points to this team, 9 into 3, 27. Okay, we need 5 more points to get 32. So even if you make it 9, 5 and 1, okay, so let's say we have the scoring 9, 5, 1. So 9, 5, 1 into 3, 27. And the other team has scored 11 points and won the rapid fire round. So rapid fire round, this team has won 3 points in 3 rounds, and 9 would make it 12. So that is also not possible. Okay, so we took all the possibilities and eliminated them. Now we are left with just one case, and that's how we are going to solve it. So it is said that we figure out this out, that 7 is the winning point. 7, 4, 1. So 7, 4, 1 in the second round also. 7, 4, 1, 7, 4, 1. Now let us name these teams. So this is Team Ashok House. This is Gandhi House, and this is Vivek House, right? So if it wins this round, so it will end up with 11 points. Okay, 4 rounds, 4 points, and in the 5th round they score 7 points. And if they get 4 points here, they will end up with 32, and if they win 1 point here, they will end up with 17. So all things match. 32, 11, 17, they are winner of this rapid fire round. So this is called rapid fire round. So it required a lot of hit and trial, but the key thing here was figuring out that the total is 60, and it has to be a multiple of the sum of points distributed in each round. So if you were able to hit that, then only you would have proceeded in this set. If you were not able to figure that out, then probably you will end up spending a lot of time and still not able to solve this set. So although this text looked very short, but it was very intense in logic. What is the value of A? The value of A is 7. How many rounds did Ashok House finish first? So Ashok House finished first in 4 of the rounds. If one of the rounds was a buzzer round, who finished third in that round? Okay, so this is rapid fire round. Any of these rounds could be buzzer round, and in all these rounds we see that Gandhi House is finishing third in that round. Which of the following statements is correct? Gandhi House came second in one of the rounds, so it did not come second in any of the rounds. Wrong. Vivek House came third in 3 rounds, so it did not come third in 3 rounds. Exactly 2 rounds had the same score for all teams. See, one of the rounds is a different score, and there are 4 rounds that have same score, so that is also incorrect. Ashok House did not come third in any of the rounds, so this is the true statement based on this information. Okay, so this is how we are going to solve this set. Do let me know in the comments that were you able to solve this set on your own or had to look at the solution to solve this set. If you are preparing for CAT and other MBA entrance tests, we are launching a test package for all these exams, and this month we are offering 20% discount on the same. So you can use the code HOT to get 20% off, and in this we will provide CAT mocks that will include 15 full length plus 10 sectionals each, and we will provide mocks for all other MBA entrance examinations that you can think of, like NMAT, SNAP, ZAT, CMAT, MHCT, CUET, etc. And seeing this good response of the series, we have got a lot of queries about our course for CAT. We already have a batch for CAT running, as I mentioned about it previously, and we are also planning that we might launch a crash course in September for those students, especially those students whose concepts are already clear, know the basics, probably they are the repeaters, and last year they had prepared but want intense preparation towards the end and a good revision for the syllabus. So we will be launching this crash course somewhere in September, and we shall announce it on our YouTube channel, our Instagram page, and on our Telegram group as well. So please don't miss out to subscribe to all of these, so that you don't miss out the information about this batch, which will be launched very soon. So there is one set for you to solve in the as a homework. So take a screenshot, solve the set, and answer the questions in the comments of this video. And also let me know that which of the sets that we discussed in this video were you able to solve, which was the best one. Try to rate them in an ascending order, that which was the best one you liked out of those. So that's for this video. I hope you enjoyed solving these sets. So we have 5 more days to go for this, and do watch the entire 30-day series. That will boost your preparation for CAT and other MBA entrance examinations. So thanks for watching this video. Have a great day ahead. Goodbye.